Hi everyone, welcome to VLSI for All. We are back with yet another podcast in which we invite VLSI experts. I am Apurva Dikshit, today's host, and we are honored to have our guest today, Gaurav Goel, sir. So before we start our podcast, I'll start with a little interview about your career. You have about 2 decades of experience in designing cutting-edge DDR5 controllers and high-speed interface devices. You have also contributed to some of the most innovative advancements in VLSI, having worked with Intel, AMD, and Renesas. You have expertise in high speed memory technologies, and you have great passion for mentoring youngsters and the next generation of engineers. And we would like to start with a question. Can you please give a little introduction about your passion and where exactly you're working?
Thank you, Apurva. First of all, thank you for having me here. So, let me start from the very beginning. I started my career 21 years ago, and at that time, I started as a verification engineer for an Indian services company. I was not really sure if I wanted to do verification, but it was a good learning experience. And after 1.5 years, I started working in design. And since then, I've been working in design and architecture, of course. So, it feels like while you were reading, it suddenly felt like, I become a dinosaur from the Jurassic era. Well, that was not the intention, but yeah, I think the passion for VLSI comes from the fact that it is something that you design and you see it working the way you wanted it to. The first chip that I had designed was for analog devices long ago. When that chip came out from the fab, we tested it in the lab. I was so excited. I actually brought my camera to work. I took photographs of it. I sent it to my parents and I wanted to, show it to them. See, it actually works, right? So this piece of sand is actually doing what I asked it to do. So that is what makes engineering, especially VLSI, very cool. The biggest highs you get are when you design a processor, it comes back alive. You can see the operating system loading, you can see different things happening. The kick that you get out of that is what motivates you to keep working. So, like I mentioned, so I started from a services company. After that, I went to uh, an MNC, which was analog devices. And I started working on these analog and mixed signal chips. Okay. Yeah. For the initial part of my career, I worked in the video space, video encoders, decoders, etc. And it was fascinating. And I used to think that is what I would like to do for most of it.
Okay.
I accidentally came into the memory space. So when the recession happened, I was at that time working for a Sweden based startup and it went bankrupt. And
Oh,
that was the time I moved to Intel, and the opening was for a memory thing. And I then realized that, oh, well, this is really interesting. This is what I would like to do because all the compute in the world right now is hampered by the lack of memory. The processor is fast, but it can't fetch information fast enough. So, and that's how I got into the memory space. And I think I've been working in memory space for more than 15 years now.
okay.
So across Intel, AMD, and now Renesas. So it's been an interesting journey.
So very inspiring, sir. But let's go to the beginning of it all. What motivated you to go into the VLSI industry? Like the education, where did you receive your education, and how did you being pushed into this domain?
I never wanted to be in VLSI. I did not know what VLSI was. I wanted to be an astronaut.
Oh wow.
And I ended up in NIT Trichy. I did my bachelor's from NIT Trichy. When I went to college, I was like, well, yeah, I didn't become an astronomer or an astrophysicist. It's okay. Let me do engineering. I landed up, I did engineering, and maybe in the second year, I realized, oh, okay, A, I think I'm good at it, and B, this is really interesting stuff.
Interesting.
So, and by the time we were in final year, I realized, okay, this is what I want to do. I want to design a processor.
Oh,
So that's what motivated me to be in VLSI. So by the final year, I was very clear, I don't want to do any software job. I want to be in VLSI.
Yeah, because many people switch actually from the
Yes.
hardware, even if they have done their graduation in hardware,
Right.
because there's more money and more opportunities in
That's
terms of job and so growth as well. So what do you think about growth in VLSI industry in terms of that?
I think the VLSI industry is growing quite well, especially in India, if you see. Um, as long as there is a need for compute, the VLSI industry will grow. So when I started my career, the boom was due to the dot com,
Okay, yeah.
okay, e-commerce.
Mhm.
Now the boom is because of artificial intelligence. What is common to all of them is that they need fast, reliable hardware.
Mhm.
There cannot be any software engineering marvels without having
Hardware.
suitable hardware.
Yeah.
If it was the likes of Intel which fueled the first wave of compute, the likes of Nvidia, for example, are responsible for this one. But the point remains that hardware will always be required, and hence the industry will grow. In India specifically, from the times I started working, there used to be a handful of VLSI companies. Right now, if you see, all the major semiconductor majors have a design center in India.
Yeah.
And it's no longer a back operations job, right? People are absolutely working on cutting edge technology in India. So I'm quite optimistic about it.
Okay. So you have worked with the giants like Intel, AMD, and Renesas. How was your experience, which shaped your designing approach?
So that's an interesting question. So Apurva, I worked with Indian Services Company, a smaller MNC, two large semiconductor giants. I'm working for a Japanese MNC now. All the experiences have been unique in terms of culture. And in between, I also work for a startup. So the every place teaches you something different. When I was working for the startup, we were strapped for funds. We didn't have enough funds for buying fancy tools. When I was working in Intel, we would go and use the best tool in the industry. So, what happens is that you learn different culture from different places. In some places, there is more emphasis on speed of execution and time to market. In some places, there is more emphasis on uh, getting the details right the very first time. And there is space for both these approaches in our industry, right? In some places there is more focus on streamlining the processes. In some places there is more focus on just getting the things done as fast as possible. I've seen all of them, and I don't think one is right or the other. But the other thing which has been interesting is working with different colleagues, stakeholders, customers from different geographies. So I have worked with folks from Japan, China, Europe, America, Israel, and the cultural sensitivity that is required varies. And so, not a lot of people put a lot of emphasis on learning soft skills during engineering, but that is something that is important and helps drive your growth.
Okay, okay. All right. So, when we talk about the startups versus these big giants,
Mm.
where do you think the young mind should go? Where do they learn more?
I think they should go to both. Okay, at
Have
different
a taste
phases
of
of
both.
life.
Hmm.
Okay,
Okay.
there is always a trade-off between width and the depth. So if you want more breadth, uh, you can go to a smaller place because you will end up doing more hands-on in one place. And if you go to bigger giants, what
Mm.
happens is your role might be slightly restricted, but you will have more in-depth understanding within that. I'll give you an example. When I was working for that startup, uh, not only was I the designer, FPGA prototyper, I was also managing the lab. When I joined the company, the first day my manager introduced me to the lab, and that was the lunch space. So I kicked everyone out, and we ended up setting up the lab. So Uh, so you learn different things in different places. I have soldered stuff myself. I have debugged oscilloscopes.
Oh,
Okay. So, and so that kind of stuff you will learn in a smaller company. In bigger company, you will have the opportunity to work with the subject matter experts. So I had the opportunity to work with some very, very good subject matter experts. And those kind of experience you'll get in bigger companies. So my advice to the younger crowd is work everywhere and find out what kind of a person you are and what suits you.
okay. So, as you have shown interest in mentorship,
Yes.
right? So, there I wanted to ask, what was your experience? Did you find someone in your life who pushed you in the right direction? What is the importance of mentorship?
So I am very passionate about mentorship for the reason that I found very good mentors during my journey. I have been very fortunate that I found good managers and mentors right from my analog devices days to Intel. Uh, I found a very inspiring mentor in Intel who is still my mentor, even though we are not working in the same company anymore. We still remain in touch and he still remains my mentor. Because mentorship provides you a personalized learning experience. A mentor is a person who pulls you out of your comfort zone, doesn't let you whine, pushes you to become the best version of yourself. So that is why mentorship is important. Unfortunately, I see a rising trend these days that not too many people want to invest in fresh graduates. Okay, everybody wants experienced people. Everybody wants people who have already done that. Unfortunately, the problem with that approach is that we are not investing for future.
Mhm.
Um, I like to work with college grads, recent college grads. I like to mentor them. And what I've realized is that they have the freshest minds, the freshest ideas, least bias. And as they grow, so does your skill set. Because mentoring a person not only teaches the person who's being mentored, it also teaches the mentor himself.
Hmm. Right. Because this is very important as a young mind or who has just come into the industry. They are like blank, exactly blank, where they have to go, what skills they need to learn. So either they learn by themselves, which is going to be harder, right? They have to, they will hit, deep downs,
Right.
and they'll feel demotivated in this industry because it's like cutthroat competition right now. And as you said, that there's not much of demand for fresh minds rather than experience. It's also difficult for them to get a job.
Right.
So it's really important for them to find good mentors and maybe in terms of managers or their colleagues.
Yes. So it is unfortunately a vicious cycle. We don't invest in people, then we don't find talented people, and then we say, oh, there is a crisis.
Yeah, definitely. So yeah, we need to motivate each other, definitely. Okay, so coming to next question. So this DDR memory, which we have worked on, has evolved significantly over the years. Could you walk us through the evolution from DDR3 to DDR5 and your contribution to this field?
So DDR has been mainstay as the main memory type for a very long time now. When I started working, it was the initial time, those are the initial days of DDR3. And DDR2 to DDR3 was a huge change uh, because of the change in specification. There were new set of trainings, etc., required for it. So it was a very challenging experience. Thankfully, the mentor I mentioned to you was a stalwart and he took us through the process. In terms of the evolution of memory, what has happened is that DDR is no longer one monolith in the sense that there are different types of memories which have evolved over the years. So earlier, DDR used to be one size fits all kind of a solution. You'll put it in a desktop, you'll put it in a data center with a few variations, but it was largely the one type of memory. What has happened in recent years is that the low power DDR or the LP DDR has become more common in desktops, sorry, not desktops, in the laptops and tablets and devices like that. So there is a different evolution that is happening on the LPDDR side. The DDR is becoming more and more mainstay on the desktop, workstations, data centers, and we also have new type of memories now which are coming. For example, the entire AI,
Yeah.
right? You'll see a lot of, you'll see and hear a lot of information about HBM. So HBM is a new type of memory which is kind of put on top of the GPU, right? Uh, so that is what is making waves these days, right? So the memory world has changed drastically. As a result of this, what has happened is the gap from introduction of DDR3 to DDR4 was X years, but from DDR4 to DDR5 has become more than that.
Okay.
And DDR5 to DDR6 will become even more
Even
because
more.
of that. So, but the need for memory is not subsiding. The compute is growing on a different scale, whereas memory is growing on a slightly slower scale. How do you make the twain meet? And that is the biggest challenge. And that is what the DDR specification, for example, is given by an international body called JEDEC. So the JEDEC committee has been working on trying to plug that gap. So what you will see in the coming years is not just these mainstay memory types. You will also see that the data card, as we call it, it's called a DIMM module in our language. You will see more innovative forms of that. So what you will see is that we are all trying to address that bottleneck, the data throughput bottleneck problem by bringing in more innovative type of data cards like the MRDIMM, the CAM modules. So the evolution, I think, going forward, will you will see more innovation in these steps.
Okay. Coming to the AI factor. So, this is a generation of AI, and definitely in the hardware domain, also, how do you see the impact of AI? Where is it leading us? Is it leading because there's a fear of AI as well, like it's going to take all the jobs? And so, what do you feel like in hardware? How should we take it?
I think, first of all, we should not be afraid of AI. It's a tool. Every new technology, when it comes, there are people who are skeptical about it. There are people who are naysayers about it. Um, when the initial PC came, people are skeptical about it. Um, but what we have seen is that the world has changed because of that. Same way, what AI will do, definitely do, it will change the nature of jobs for sure. But it doesn't mean that there will be lesser jobs. Then the type of skills needed will change. So, first of all, we should not be afraid of AI. We should embrace it. So, the question is, how do we embrace it in VLSI? Uh, Making chips is a hard job.
Mm,
Okay. It's not rocket science, but it's not less than rocket science either.
yeah.
Okay. And when you are dealing with transistors where only a handful of atoms are left now, so it makes it very, very difficult. So AI can definitely help in reducing the time to market. It can help us to bring in silicon with better quality. It can reduce the amount of manual work required. So that is where AI will eventually help us. I see a lot of presentations these days from tool vendors who have embraced AI. You see a lot of the things. For example, the simulations you do, right? How do you categorize the failures? How do you find out what extra coverage you need? A lot of AI engines have evolved to tackle these problems.
Even for developing these kind of AI models, we need manual labor. So,
Absolutely.
yeah, jobs are not going anywhere. So, as you mentioned, that we need to develop skills also accordingly, like according to the change in the demand. So, what kind of skills would you suggest
Uh,
we should have?
Definitely, the core existing hard skills, such as I'll speak from the digital person's point of view. So, say the system Verilog and the timing closure and all of that will not change. That will still be required. some parts of this will get automated. How do you embrace the AI change in that is become very good at scripting languages. Yes. Okay. So mm, Python, for example, right? When I started in those days, TK, TCL were the mainstay. Then came Perl, Ruby. Yeah, I'm sure you wouldn't have heard of them. But
I actually have, but no use now, honestly.
so I think the important thing is to become better at scripting languages. Always question yourself: the task that I'm doing, can I automate it?
Yes.
Is there a better way of doing it? I think that is the mindset more than the skills that will help.
I mean, in terms of like personal experience, I've seen in my team running regressions. The manual labor was huge, like days and days they have to code and then analyze the results.
Yeah.
Analysis of result has become really easy with AI models.
Correct.
So we can have a customized, just UI for the results, and it's going to be better, presentable, and also faster.
Yeah,
in
and
terms of-
triaging of failures, for example,
Yes.
bucketization of failures, for
Right, right.
example.
So, and in those area, AI is definitely
Yes.
helping.
And similarly, in the physical design side of things, for example, what is the most optimal floor plan, right? For example, that uh, so far it has been kind of manual. And now with AI, you can run different configurations and find out what works better for you, for example, right?
Right.
So I think the physical design aspect of it will definitely benefit from this push of AI.
So coming to the next question, mixed signal IPs combine analog and digital words. What unique challenges do they bring, and how do you overcome them? Since you have worked on mixed signal.
Yeah, so it's a different world altogether. And I'll be honest, when I came to the industry, I did not want to work for analog mixed signal because I used to find them very hard in college.
Okay.
Okay, so it's ironic that I've ended up working on it for so long now, but uh, so the biggest difference is if I'm working on a purely digital IP, I work on the functionality, I run the regressions, analyze failures, and you wash your hands off.
Yeah.
That doesn't work with any kind of hard IPs. Okay. You have to not only do your job, you also need to understand where is your data coming from or going to. In most cases, it will be an analog front end. You have to understand what are the typical circuits used for that. Um, as much as I disliked analog in my initial phases of the career, uh, now I feel comfortable looking at a schematic and being able to at least traverse through the hierarchy.
Yeah. So it's always scary when you are
It is
very
scary.
new to a domain, and once you are being through and you're all the hardships you have been
Yes.
through, all nighters, then it gets easier.
Yeah. So the important part is that in case of mixed signal design, you cannot stop at just the digital part. You have to really understand the analog. A simple example, you have outputs going to analog. You have to understand what kind of, for example, placement issues they will have. You have to understand the physical impact of the things that you do. So that is what makes it very different from regular digital design. You also need to think about how the timing closure will happen, for example,
Yeah.
right? The reliability aspect of thing. So that is why um, working on analog and mixed signal IPs is kind of working on a mini chip itself because you have to explore all the other aspects.
Okay. Next question. So you have mentioned that hardware, firmware, co-simulations for pre-silicon testing, right? Could you elaborate on how this methodology has transformed IP design?
Yeah. So let me start with a little background. So when you work on uh, PHYs, right, whether it is DDR, which is a parallel interface, or you're working on serial IOs, high-speed serial IOs like PCIs, uh, what happens is that you end up working on the highest speed of data.
Yeah.
So which will be several gigahertz, right? The physical challenges are quite unique in those cases. As a result, what you have to do is you have to do a lot of training on the system, on the platform, right? Um, there are a lot of circuit tweaks that you need to do to get the best possible data I, as we call it, basically to have the best possible noise margin and jitter margins. So what happens is that we do a lot of custom and sometimes industry standard algorithms for that.
Right.
So in the good old days, it was enough to implement these algorithms in hardware, check them once, and wash your hands off because the data rates were low. Now the data rates have become so high that doesn't work anymore. So you do have to train them. In one of the projects that I had worked earlier in Intel, so it was a DDR5. So we had put a mini microcontroller inside the IP itself to self-train the PHY. Now, then somebody needs to write the software for it. When are you going to test it? Are you going to test it in the lab? There can several things that can go wrong.
Yeah.
So when do you test it? You need to test it pre-silicon.
Yeah, right.
So that is why the hardware, software, co-simulations become important.
Very important.
And that's very hard because A, they are slow. B, you are testing a code written in, say, C with something which is in, say, System Verilog. So it presents a very different set of challenges. So uh, as so the first DDR3 that I had worked on, the speed was 1600 megahertz, 1.6 gigahertz. Today, I will not even sweat about 1.6 gigahertz, right? If you look at the GDDRs, for example, they are already like 48 gigahertz.
Yeah.
Like DDR5 itself is close to 10 gigahertz. So now the speeds are becoming higher and higher. So the challenges will become worse. You will see more and more integration of such training engines within the IPs and the chips. And hence, there will be more and more need for hardware software co-simulations.
So coming to the young minds again, for new entrants in the VLSI field, especially those are interested in digital design, what are the core skills that they should focus on?
So the first important skill they need is clear logical thinking. There is no substitute for it. You can learn a language, you can learn the semantics of a language, but what you should train yourself for is logical thinking. When you do a design, I always tell this to my team, you're not a software guy. You're a hardware person. The minds are different. A hardware mind has to think of what all things happen in parallel. So whenever you design, the design must happen on a piece of paper or the whiteboard. The language is just translation.
Mm.
This is the first thing which will get automated.
Right.
So, but the designing, the thinking part of it will not be so easy. So you have to become comfortable doing design by first principles. By drawing it out, think, if I write a code like this, what does it really synthesize to? What kind of gates does it really, manifest itself as? Uh, you should not get into the habit of designing through simulations. You code something, see the waveform, oh, it's not working. Maybe I add this, maybe I add this.
Oh.
That is the worst way of designing.
Yes.
Design from
Because
first
this will
principle.
take forever.
Yes.
If you don't have a clear vision on your design and don't understand different scenarios in which your machine can work,
Yes.
it is going to take time. Yes.
So that is first thing. The second thing I'll say is always learn a few skills from your adjacent domain. If you are a digital designer, you must understand the basics of verification. You must understand the basics of physical design, the synthesis, place and route, etc. And a little bit about what flow, for example, the analog follows. Unless you understand this, you will not understand the requirements of your stakeholders, right? So I told you I started my career as a verification engineer. I was a reluctant verification engineer. Uh, I thank my stars for that now because it helps me understand the language the verification guys speak now,
Okay. Okay.
right? So that was an important lesson as much as I did not appreciate it at that time, right?
Mm.
Similarly, I've had a lot of interaction with the analog folks during the journey, and I now understand what they require. So it is important, right? So
Mhm.
always don't restrict yourself to your core system Verilog skills in the lab. When the chip comes,
Yeah.
spend time in the lab. Go
Okay.
see. I often tell a lot of young engineers, the clock you draw on the board is not how it will appear in the lab. If you are lucky, you will see something sinusoidal. Otherwise, it will be even worse.
Okay. Okay, all right. So, if a person is working in one particular domain and they want to switch, or would you suggest that they need to go into different domains and search what they exactly are interested in? Would you suggest that, or you think that expertise in one particular domain is very important?
When you say domain, you mean like, say,
Digital versus analog.
okay. Uh, when you're just starting your career, obviously at that time you don't know what exactly is the right fit for you,
Right.
right? More often than not, you get hired for a team and then you just adapt, right? Uh, in those early years, yes, I'll say do explore, figure out what is it that excites you. Okay. Uh, but I don't think that's a good advice after you've spent some time in the industry,
Right.
right? Because then you kind of lose whatever you have already spent time on. There, if you want to then build expertise, you can consider sticking to a certain field or a larger field. For example, I have been working on different things associated with memory industry, and before that, I used to work on video industry, right? So
Right.
that is something that you can build upon and also can switch between different domains. But switching between, say, verification and physical design or analog later in the career is not suggestible. But
Okay.
initial years, yeah, definitely. And most importantly, always have the curiosity to understand what somebody from the other domain is really doing.
Doing, yeah.
Even after 21 years, I still go and bother my colleagues trying to understand what is this, and I ask them dumb questions.
Yeah.
So don't be afraid to ask questions. Do not double guess yourself and remain curious.
Remain curious, right? So next question. How can young engineers add value to teams working on high speed memory and mixed signal designs? How can they contribute?
So I have a young engineer in my team with just 1 year experience. So unfortunately, memory domain is not something for which the spec is nicely laid out and you read the spec end to end and you understand. It's not the most friendly spec, if I have to say that.
Okay.
Uh, so it takes a while to ramp up. Okay. Uh, the engineer I'm talking about, he took his time to ramp up on that. And it takes time, right? So the most important thing is to have patience while doing that, because there is years of history behind why certain things were done. To unravel them one layer at a time, it takes effort.
And we cannot expect proper documentation of all those developments. Definitely not.
So I think you have hit the head of the nail. So documentation, unfortunately, is something we engineers are not good at, and we don't really understand the importance of documenting either. Right? Like I mentioned, these are some of the soft skills which must be absolutely mandatory
Yeah.
when the engineers enter the industry.
Okay. Okay. So next question. What resources or tools would you recommend for someone looking to build expertise in memory interfaces and PHY design?
Hmm. So the resources, okay. So the first thing is, if you want to learn about memory, there are a lot of good tutorials about a where does the memory really fit in the DRAM, for example. It talks about the basic protocol, right? You can find them in many places over the internet, right? So start from there,
Hmm.
okay? After that, you should start looking at the spec. The spec is not to be read from end to end. Go figure out the topmost parts first, then go deeper into it. In terms of the languages, you don't really need any specific languages. What you need is to always have a view of the system,
Hmm.
because DDR is something that does not work in isolation. It's an entire ecosystem that composes of the host CPU, It contains the memory cards, the DRAM device makers, and there are a lot of other extra chips that go onto the memory cards or the DIMMs. There are data buffers and the clock buffers. So whenever you are trying to understand, approach from a system perspective. Approach from the perspective of somebody in the lab who's going to use that system. Okay, host is sending it, this guy is receiving it. Oh, it's a long trace. The eye would look terrible. So what do you do about it? Oh, you train it. Who trains it? How do you train it? You read upon that. So approach it from tops down and not bottoms up. So
Okay.
always try to figure out, why do we have to do so many trainings? Why is there so much handshake needed between all these components? Right? So important thing is to keep the system level mindset.
Okay. Asking this particular question in a very generalized term, let's suppose that people are looking for a job, fresh graduates or experienced people. What skills or what resources or tools they can use in order to improve their knowledge or prepare for an interview? What would you suggest?
So the first thing is, work on your competence for on system Verilog. Okay, I have interviewed I don't know how many candidates who turned up for interview unprepared.
Okay.
So don't do that. Spend time to learn the semantics of the language. I'm not talking about syntax. Syntax
Okay.
anybody can learn, to understand what gets used where and why, right? Learn about the flow. When a lot of engineers come into the VLSI industry, they do not know the complete flow, right? From the requirements that come from the marketing folks, to how it translates to high level architecture, to lower level architecture, design, physical design, packaging, post silicon bring up, all of that.
Okay.
So that is something you should invest time in learning. I did see VLSI for All does have some of these
Yeah.
videos, right?
Yeah.
Right.
Lectures.
That's a good start.
Mhm.
There are similar such courses from NPTEL, for example,
Yes.
right? I do know there are a couple of professors who are very popular.
Mm.
Professor Indranil, for example, who have given very good tutorials on it. So spend
Right.
time on that. And the next most important thing, how do you learn to ride a bicycle? By riding it. You will fall, you will get up. You'll fall, you'll get up. So code.
Get experience of
Yes.
interviews.
Go to GitHub,
Yeah.
code.
Okay.
Okay. You don't really need fancy EDA tools to simulate. You can get cheap simulators. So try it out.
Okay. So the languages you are telling is System Verilog.
System Verilog, Perl. You must learn about the flow. So that is why you should learn about the basics of synthesis, right? Um, which can be from either of the EDA vendors. Okay. And you must know how to analyze timing. Unfortunately, this is something not too many universities spend a lot of time in. They will teach you the definitions of setup and hold time.
Yeah.
Unfortunately, people will not be able to
Practical
read
use of.
practically a timing report and see, oh, this is the problem. So that is something you should spend time in understanding.
Yeah. UVM also.
Yes, UVM, of course. I mean, of course, from a verification perspective, UVM is definitely very important. And since the analog digital complexity will keep on increasing, it is actually it would be a good time to invest in modeling languages such as Verilog ANS, for example,
Okay.
right? So, uh, because that is one of the other pitfalls of mixed signal. You need a good model of the analog. So there are a lot of opportunities in that field as well.
Do you see that the demand for expertise in Python or such AI languages is also required these days?
Yes, it is required, but it will not be the main skill set.
Okay.
It will
Plus one.
definitely be an important additional skill set. So the basics of system Verilog or UVM for verification or the tickle scripting needed for physical design, that will still be there.
So coming to our next question, open source contributions in VLSI are growing. Do you see a space for collaborative development in proprietary technologies like DDR5s?
So Theoretically, yes, that can be there. But what happens is that um, as far as the important processors are concerned or important SoCs are concerned, everybody is looking for a DDR5 which provides least latency, occupies least area, and also consumes least amount of power. Of course, these are conflicting requirements. But what happens as a result of that is that everyone designs their own DDR5 when they have such stringent requirements.
Yeah.
That does not mean that uh, open source technologies cannot exist for this. It can exist, but the number of people who would be looking for them would be on the lower side. The reason is that, for example, there are IP vendors already in the industry who are providing DDR5 IPs, for example.
Okay.
So, in my opinion, the chances of an open source DDR5 becoming like the de facto accepted solution, I think the chances are low as of today.
Okay. Do you support open source, say, chips?
Yeah, open source is a great thing, but
Yeah.
we have to remember that this is a business, so somebody needs to make money.
Yeah, that is the reason why I think it's not available that much as
Yes. I think open source makes a lot of sense in a lot of other initiatives like the RISC-V, for example. So, uh, but probably in certain interface solutions like DDR and high-speed serial I/O, probably not the right solution.
Okay. So since you have spent about 2 decades in this industry, what has been most rewarding project in your career?
The most rewarding was um, in 2017, I started a team from scratch. I think I had 4 or 5 recent college graduates from the top-notch colleges, the IITs,
Okay.
but that's it. And who naturally did not have any prior DDR experience. We started the team in India.
Okay.
Now, you must remember, not too many people want to invest in a brand new team of inexperienced people in a low-cost geography like India, right? Um, so that was personally very rewarding for me because the team did very well, um, and we were able to tape out multiple chips, multiple IPs.
Okay.
Out of that, we were able to grow the team. We were able to deliver multiple IPs across different protocols like the DDR, LPDDR, and driving innovation. Like I mentioned, we had added the microcontroller self-training engine inside it.
Okay.
So,
Yeah.
which was something that a lot of people used to talk about, but people were afraid or hesitant to get into it. And that was, for me personally, very rewarding because that was not just a technical challenge. There was also a non-technical challenge of convincing the other technologists that this is the path forward. So uh, there were a lot of discussions about the trade-offs, the ROI and the complexity and everything. When the chip came and it booted up in just a few minutes, I mean the training part,
Mm.
that was the most rewarding part.
The most difficult journey when it gives fruitful
Yes,
results. That is
yes,
the most rewarding
that's right.
project.
So that was for me personally very rewarding.
Yeah, right. So, if you could give one piece of advice to your younger self, what would that be?
Don't be afraid to fail
Okay.
because what happens is that all of us build some safeguards around us. Okay. I was a good student. I got good grades throughout, but I think that also kind of made me risk averse after a while, and that is not a good thing. And uh, over the years, now I have always tried to push myself. For example, I moved out of one company where everything else was going great, everything was fine. I just felt I had become too comfortable. So I
Okay.
just got out just to challenge myself. Every 3 years, you should reinvent yourself. Keep reinventing. The world remains a classroom. So I would tell myself, don't stop learning. Remain curious. Don't be afraid to fail.
And don't get too comfortable. Challenge yourself.
Yes.
So yeah, every day you should at least learn something new, right? So, if not working on high-speed memory and interface design, where else in the tech world would we find you?
Hmm. I enjoy mentoring people. I enjoy teaching them. If I was not designing chips myself, I would probably be uh, running some kind of an academy, teaching students about VLSI, about the different protocols, maybe.
We'll look forward to it. Maybe in next few years.
Yes, sure.
Maybe okay. So finally, for fun, we are asking this question: if you could design a dream chip with unlimited resources, what would it do, and how would it revolutionize the industry?
Okay, all right. So I think if I had infinite resources and infinite, I mean, funding and time, what I would like to do is to build a GPU
Okay,
from scratch, a made in India GPU
competition
for
to
India,
India.
for India,
Okay.
for solving our problems.
Hmm.
So because I think there is a lot of talent available in India. Um, we do see a lot of startups trying to work in that space, uh, but we still have a long way to go.
Yeah, maybe resources are missing or funding. I don't know.
Exactly.
Yeah, but India is still lagging behind in these terms. Right. So you wanted to share some fun story.
So I'll tell you a very interesting story. So uh, I think almost 10 years ago, this happened. I was working on a high speed serial IO chip at that time. Um, it was a fairly challenging project. It was a challenging power on. It started working eventually. Power on was in Mexico. We came back to India and it was working fine. We breathed a sigh of relief and suddenly we started hearing back from our folks in lab. A particular bench is not working. A particular platform is not working. They tried debugging it from North America. We did multiple experiments. Nothing really worked. And we were like, why is this not working? This is not making sense. Uh, we eventually flew back to me and my analog counterpart. We flew back to Mexico to debug it. And we tried so many things. Nothing was making sense. Out of sheer frustration, I tell my colleague, maybe the Vastu is not right at this place.
Okay.
Let's move this platform to another part of the lab. We did that. Guess what? It started working.
Working.
I was like, what just happened?
Picked something.
So then we eventually figured out that the lab had recently purchased new chairs, which were being used in some parts of the lab, and there was some electromagnetic problem
Oh, yeah.
with those chairs. So the ESD, so the static charge was problematic.
That was the problem. Okay.
So we flew across the globe to find out that the chairs were the culprit, not the chip.
Somewhere Indian culture helped. Okay. Thank you so much, Gaurav sir, for coming to our show. This was very insightful and inspiring podcast. We'll see you for another one. Thank you.
Thank you, Purva.
Thank you.